All right, we have a lot of homework problems that I want to do in this video. I'm going to try to slow down, but it's really nice outside and I need to go for a run, and I'm going to do it after these videos, and I'm worried it's not going to be nice outside anymore. So if I start speeding up, say, Jason, slow down. Go enjoy your sunshine later. We're important now. Number 14. All right. So number 14 in 6.1 is up here. And it says, determine the equation whether it represents exponential growth, decay, or neither. So this is 300 times 1 minus t to the fifth. This is not exponential growth or decay. Remember, exponential growth or decay is in this form or this form. This is in neither form, right? Our variable has to be in the exponent, otherwise it's not an exponential equation. Right? Variable in exponent. This is a polynomial, right? This is a polynomial. It has a 0 at t equals 1, multiplicity 5. Tie everything in together, right? This is a polynomial. It's not exponential growth or decay. Let's do 16. Y equals 16.5 times 1.025 to the 1 over x. So this isn't in the right form either, but it's very close. Wait, no, it's not. It's not in the right form, and it can't be the right form. Negative exponents mean reciprocal, but fractional exponents are radicals. All right, this is 16.5 times the xth root. This is a radical. This is not an exponential equation either. What does this look like? This function's got to look really weird. You can also check your answers with Desmos. Let's do that. Look at the first function. Y equals 300 times 1 minus t to the fifth. Oh yeah, this is not exponential. That's definitely cubic. And the second one was 16.5 times 1.025 raised to the 1 over x. What is this? Yeah, okay. Yeah, so this has an asymptote. When x is equal to 0, right, this is not defined. It's certainly not exponential. You can always graph when you're in doubt. This is not exponential. This isn't even a radical equation. Radical equations have x's on the inside of the radicals. This is just, I don't know what this is called. All right, let's do 33 and 34 next. I think these are interest problems. Yep, solve the compound interest formula for the principal P. A is equal to P. Oh, wait, hold on. I haven't checked it yet. It's PAL. I would have guessed wrong. I guessed PLE. It's PAL. All right. Unless the book is wrong. Solve for P. Okay. 1 plus R over N to the NT. So to solve for P, well, it's just P times something. All we have to do to solve for P is divide by that something. That's it. We're basically done. That gives us that P is equal to A divided by 1 plus R over N to the NT. This is a good answer. It actually looks a little nicer if you write it like this. You can think about this as a negative exponent. Negative exponent means reciprocal. The negative exponent being applied to this is the same as this part being in the denominator. This is actually my preferred one. But I'll take either answer. And 34 says, use the formula in the previous exercise to calculate the initial deposit, find P, For an account with A is 14,472. 74. It's our A. Divided by 1 plus R. Our interest rate is 5.5%. As a decimal, that's 0.055. Divided by N, it's compounded monthly. N is 12. Raised to the N times T, how many years? 5 years for number 34. And you can simplify this, but it's honestly best you get the least amount of rounding error if you just type this all in at once. Okay. So we're going to go over to Desmos and say, all right, what is 14,472 74 divided by 1 plus 0.055 divided by 12 raised to the 60th power. Or you can do 12 times 5. And it says round to the nearest dollar, so we're going to round to $11,000. That's how you use this formula. This was the initial deposit, and it was worth $14,500 after 5 years. Number 40 is next. Slow down. Oh, the sun went away. The sun's behind a cloud. It'll come back, I'm sure. I'm sure the cloud's not that big. Let's do number 40. Number 40 says, determine whether it's, all right, continuous growth, continuous decay, or neither. This is going to be the same as the other problem, right? That T is in the denominator. This is going to be a radical, right? It's same as that earlier problem. Same as, I think that was 16. But to explain it a little bit more thoroughly, right, we have y equals 150 times e to the 3.25 over t. Definition of rational exponents. The definition of fraction exponents means this is the same thing as 150 times the tth root of e to the 3.25. Again, same situation as before. So it's not exponential growth. It's not exponential decay. It's neither. And if you graphed it, you'd see that. Number 48. I'm recording all the videos for 6.2 after this, so it's not even like I'm going outside after this video. It's okay though. Number 48 says, evaluate each function, round to 4 decimal places. This is actually, coincidentally, almost the same as the one we did. It's not a coincidence at all. I stole it. It's the same as the one we did in the other video. Well, let's do number 50. More practice for number 50. That's going to be f of x equals 3 halves times, negative 3 halves times 3 to the negative x plus 3 halves. And you want to find f of 2. So again, as a reminder, we cannot combine these. It's very important here because one has an exponent and one doesn't have an exponent. If we had this, then we could combine, but we don't. All right, so all we do is plug in negative 3 halves times 3 to the negative 2 plus 3 halves. And again, it's the easiest and you get the least amount of rounding error if you type this in on Desmos all at once. That's what I would recommend. Negative 3 halves times 3 to the negative 2 plus 3 halves. 1.3 repeating, or 4/3. However you want to write your answer here. You could also do this by hand, right? This is -3/2 times 1/9. 3 to the -2 is 1/3 squared plus 3/2. And then we get some cancellation here, right? 9 goes into 3 times. Whew. That'll give us -1/6. Get common denominator. 3/3. That's going to be 9/6. That's 8/6 or 4/3. All right. Last problem I want to look at. Let's look at 63. That's a bit of a longer one. 63 says in the year 1985, a house was valued at $110,000. Let's write that down. 1985, house, already forgotten. $110,000. Man, I'd like to buy a $110,000 house. Anyway, it's not 1985. By the year 2005, it was $145,000. Oh no, these are old prices. And the question is, what's the annual growth rate between these 2 years? Exponential growth. So that's the first part, was the annual growth rate. And the second is, what was the value of the house in 2010? So this is just going to be similarly to before. Y is AB to the X. Starting value, it doesn't matter when the house was built. The starting value for purposes of us is whenever we want X equals 0 to be. So let's let X equals 0 be 1985. This is X equals 20 here. And this is X equals 25 here. So then our starting value is 110,000 for purposes of this problem. You can also simplify a little bit by having Y be in thousands of dollars, but we don't need to do that. And now all we do is plug in this point to solve for B. So Y is $145,000. A is $110,000, and X is 20. So divide over $110,000, you're going to get 145 over 110. That simplifies more. I just canceled the zeros. Simplifies more, but we're going to use a calculator anyway. And then take the 20th root of both sides. To undo b squared, we'd square root. To undo b cubed, we'd cubed root. To undo b to the 20th power, we take the 20th root of both sides. Or b, our annual growth rate, is the 20th root of 145 over 110. And remember, to do radicals, you can also do rational exponents. 20th root. Like so. And again, make sure you have at least 4 significant figures besides, like not counting that one. The 1.01391. About 1.4% growth per year. And again, that's what it's asking. It's not asking our B value necessarily. It wants 1.391% per year. That's what it's asking. That's how it's growing. Converting this part to a percent. Right? Just like that earlier example, if we had 9% growth, we wrote it as this was our B value, but it's 9% growth. And in 2010, just use our formula. Y is equal to A times B raised to the X, which is 25. And we'll round to the nearest dollar for a home. 110. Hold on. We can just keep this. This is our B value. No, let's not do that. 110,000 times 1.01391 raised to the 25th power. 155,374. This is how much the house is going to be worth approximately in 2010. That's assuming that the growth rate is constant. For anyone familiar with housing prices, something happened between 2005 and 2010, but we won't go into a history lesson right now. But if it grew at the same rate, that's what it would be. And that's how you solve these problems. Let me know if you have questions, and good luck.